Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through some of the major topics facing importers and manufacturers in China today. Hi everybody, welcome along to episode 55 of the podcast. That's more than a year's worth of podcast episodes so far. I'm joined by our CEO Renaud, and today we're talking all about rapid tooling methods for prototypes and comparing some of the different ones. So Renaud, first of all, how are you doing?
Hey, not bad, not bad. Getting into the rainy and hot season, so just like every year, it's a bit painful.
Yes, yeah,
How
you got to
about
be
you?
careful. Even with an umbrella, it's you'll be absolutely soaked.
Right.
You know, I've been there a
Okay.
few times.
Yes. Yeah, let's kick it off. Rapid prototype. Yes.
Yes, yeah. So rapid prototyping and the tooling for that. So to kick off, what is it?
Well, if let's say you want to make a new product, and we're going to focus, as in most of our episodes, let's focus on electromechanical products, right?
Yeah.
Mechanical parts with electrical or electronic parts. Okay, so you want to develop your own product. And it's new, and it's very new, and it's sort of different from anything that's already on the market. You can't just go to a factory and say, okay, here's my sketch, do it, right? You need to make sure that um, it's it feels right for the users. Technically, it works. Altogether, the bill of material doesn't go into very high total costing, and so on. So there's a
Hmm.
number of different risks that you want to avoid. And anyway, the manufacturer will need prototypes anyway to know what exactly they have to do right. So um, you could say, okay, I'm going to work with an industrial designer, and we're going to go through the mechanical designs, and we're going to know exactly what the enclosure will look like, and the dimensions and the tolerances and everything. And then we're going to work with, let's say, this couple of sensors and maybe a little motor and some electronics to control all that. Okay, let's go directly into the design of our custom PCBA. Let's let's buy the parts that we need. Anything that is custom, let's just design it right away, and then without even thinking, we're just gonna open the tooling for the plastic injection molding enclosure,
Hmm.
or maybe it's aluminum or something else. But if there's some tooling, no problem. Let's just do it, And then you have all of this. You've already spent, $50,000 or $100,000, and you have something. You have some parts. You have all your custom parts coming out and the standard parts, and you put them together, and you're like, well, this doesn't look right. Oh, I show it to users. They tell me that they don't care about this function. Oh, and there's this and this issue, and then when we test it, it doesn't perform at all like we want, and then it fails very fast. So I some companies do what I just said, and they're in for a very painful awakening most of
Mm.
the time, because they have not taken the risk out of their product design. They have not validated it. They spent a lot of money to make something that then they might have to scrap
Mm.
because um, maybe it just doesn't work the way it should be. Maybe the users don't even understand how to use it. Maybe, right, it doesn't have the effect it's supposed to have. Maybe there's something that they didn't think about it. Oh, it makes a lot of noise, it's kind of scary to the user, or anything, right? Basically, any new product design comes with a lot of risks. And to remove risks, you need to make the what they call the minimum viable prototype, right? It's not minimum viable product. It's really minimum viable prototype when you're talking about
Hmm.
hardware products. And how do you get to that minimum viable prototype, you know, fast, without spending a lot of money, without spending a lot of time? Well, you're not going to open the tooling, fabricate the tooling and everything. you're going to take shortcuts, right? And typically, and here I'm talking mostly about very new and complex products with a lot of risk, you do a proof of concept prototype first with the main one or two features that it's supposed to have, and you want to get there as fast as possible. It doesn't have to look good. It doesn't really matter. It just has to function, you know, in a crude way, but at least you see how it works and you learn from it. You observe it, you test it, you get a little bit of feedback from users. And then after that, over time, you have other rounds of prototypes just to get to the point where you have a prototype that looks good and works the way it's supposed to work. And until that point, probably you have not opened any tooling yet. Okay, so I mean, as much as possible, avoid opening tooling by that point.
Yeah, yeah.
So when people talk about rapid prototyping, it just means they have a product design, and the product design calls for, let's say three custom parts, mechanical parts with a custom design, and they just need to get these parts made, sort of whatever it takes, in a most simple way. So the most common ways at this point are either adding material or removing material, right? So adding material is what people call 3D printing.
Mm-hmm.
Can be done on plastic, on metal. I mean, the technology keeps improving, and you can, once you have designed a part, custom part, and you have the 3D drawing, it's a breeze. It's very easy usually to get it 3D printed, as long as the dimensions are not very large, and as long as you don't need a lot of colors and things like that, of course. But if it's one material, one color, not very big, there's not many limits to what you can do. And the other way to get there is to take a block of material, usually like a solid, like a cube. Imagine a solid cube of material, whether it's plastic or metal or might be some other materials, but it's much less common.
Yep.
And you use a CNC machine to machine the material out, just like a sculptor is going to create his piece of art, right? And this is on a CNC machine. If the part is going to rotate and the tool is going to be stationary, it's a lathe machine. The opposite, when it's the tool that's rotating, it's a milling machine, which usually for these kinds of applications, rapid prototyping is more often what you would need. But really it depends on the geometry of the part. So that's rapid prototyping, basically going straight to having something physical, some parts that you can touch, that you can use to put together your, a prototype of your product without investing in tooling, without spending a lot of time waiting for it.
Good summary. I mean, this is somewhat connected with our topic from last week, which was the pre-production samples as well, because I mean, these different rounds of prototypes, they are in effect different PP samples, right?
Correct. And as we mentioned last week, you want to make sure that the pre-production sample that you approve is as close as production as possible in the materials, in the production processes, and so on. So typically, the final pre-production sample that you should approve, if tooling is involved, then the tooling has been fabricated by that point. Let's make a distinction here between two things.
Yep.
You do rapid prototyping by creating custom parts with 3D printing, with CNC machining, or with soft tooling, okay, or a few other methods, but these are the most common. That's rapid prototyping. Now, rapid tooling, when people say rapid tooling, they mean tooling in silicon rubber, or tooling in very soft steel, or sometimes in aluminum, but that's not common in China. Usually, um, yeah, people are just used to making it in steel, so they will make it in soft steel P20, for example, right? And this kind of tooling can be made faster because when you let's talk about plastic injection molding here, because that's what I have in mind. When they're going to make the mold and the different pieces that make the set, right, of the mold. Um, they start from basically, again, a block of metal, right, a block of steel. And the harder the steel, the longer it takes to machine the material away, right? So if it's soft steel, the mold can be ready faster, and it's faster to make fixes to it too, right? To make the adjustments, so they can get to T0 samples, T1 samples faster, and then when they do the trials, they can adjust also, relatively fast.
Mm-hmm.
And yes, a lot of PP samples are made that way. And then, yeah, the final one that you approve, well, maybe you made something, you fabricated a mold that is in soft steel, but still, you can still use it for 5,000 or 10,000 shots or 20,000 shots. So that's fine. That's fine. This is going to be used for mass production. It depends on the grade of steel of the tooling, but also on um, different factors. Some plastic polymers um, will get the mold, how to say, used up. What's the correct word? Basically, going to end of life much faster, right?
Yeah.
And also certain geometries of the parts will have an impact, right? So it's the key is whatever is going to be used in mass production, basically.
Yeah, okay. To illustrate what you're talking about, we do actually have a table which kind of compares the different technologies, which is on a page on site. It's a guide to rapid tooling prototyping. So at this point, I will put that guide into the show notes, and you can go and have a look at the different options. So you've got 3D printing, CNC machining, silicone, as you mentioned, soft steel, and then you've got your hard tooling, which would typically be for mass production of quite high amounts, and that's not what we're going to be doing for a number of rounds of prototyping using.
Right, and there's what I like this table because it really shows, the trade-offs,
Yeah,
basically. If you go straight into hard tooling, well, it's going to be more expensive. It's going to take longer. I see some people, some plastic suppliers. They say, "Oh, we make it in 3 weeks." You know, um, 15 working days. But that's only to trial zero, and only if everything goes all right and they get everything done on time. After that, there's trial zero, trial one, maybe trial two. You know, every time making adjustments, fixing, because they um, they typically make the mold a little bit, how to say, a little bit larger, um, meaning that the parts themselves will be a little bit smaller because they stay metal safe or steel safe, meaning that it's always better to be on the side of making the part a little bit too big, and then after that, adjusting a little bit the
yeah.
mold by removing some of the material. But then if you make the part too small and then you need to add, then you need to go into welding to add some materials. It
Mm,
gets messy, and then
mm,
it really has an impact on the lifetime of the mold, right? So when I say it's going to take longer, well, it's you know don't expect less than 6 weeks. That's what we tell our clients all the time.
sure.
And this has to be in the plan from the start. It's a big loss of. It consumes a lot of time. It's a big issue. Once it's in place and you're really sure that you're going to make a lot of pieces of this product, you're going to sell a lot, then it's great. It might go for 100,000 shots or 500,000 shots, or again, it depends on different factors, but that's good. It will allow you to have the texture on the surface of the part that you want. That's something people often forget to talk about, color, materials, and finishes, but you can't really get to the final texture that you want with 3D printing or CNC machining, right?
Yeah.
However, every time you go into real molds, even with soft steel, you can have the texture basically that you want pretty much. The tolerances, well, the harder the steel, the lower the tolerances. It's really very, very precise. Talking about half a millimeter or tenth of a millimeter, right?
Yeah.
It's pretty good for plastic parts. Of course, also you can conduct all the testing you want. That's exactly the same as you're going to use in mass production for a while. The problem with people who the downside of 3D printing, so it looks pretty simple, quick, convenient. But then we talk to people who show us designs that, number one, cannot be made with plastic injection molding, and so it means it needs to be redesigned, and then any tests that they've done on their product will have to be redone, because the physical properties are going to be quite different, probably, right? Even the material, it's probably going to be different. So you get to drop that at one point. That's my point. You have to plan for the manufacturing process that will be used in mass production, right? And 3D printing or CNC machining will take you to a certain point, but if in mass production you're going to do plastic injection molding, then you have to plan for it and already get some feedback on your designs. Design for manufacturing. Is it possible to be made with that process? And you might add some draft angles to make it easier to reject the parts. You might have to add some ribs to reinforce some aspects of the parts and so on. I mean, there's a lot of things that people kind of forget, and then, oh yeah, right. You need to get that right on the product design before you start to make the tooling, right? And the earlier you know about that, the better. So it's always a trade-off. The longer you wait, the more you can have nasty surprises. However, it's good to do short iterations of prototypes with, the quick and dirty approach does have a place.
Sure.
And the closer you get to production, then the less you want to rely on that. I wrote an article December of last year about proto testing, and that's really, it comes from a nice book by Matthew May, and that's exactly what I just explained. You make many iterations of physical prototypes of your design with different tweaks, different approaches, and things like that. And if the technology makes it easy for you to make different kinds of prototypes pretty fast, then as a product designer, that's great. You can really explore a lot of approaches, and having the final product in your hands, even if it's still very, very raw, is going to be quite helpful to refine the concept, right? That's the idea. So at the beginning of the product design and development is great. Yeah, absolutely, it's fantastic. It brings a lot of value.
Yeah, it's a means to an end, isn't it? You don't want to go into paying all of that money for the hard tooling until you're 100% sure that you've, well, or as sure as you can be that you've validated and tested the different features of your product, and that might not include texture and color and finish perhaps, but it's the more basic things, isn't it?
Yes, yes. You need to make sure that the product will actually work, um, and that the users will find it useful and will be ready to pay for it. These kinds of little details that are the difference between a successful project and a disaster that took
Yeah.
2 years of your time and $500,000.
No,
It's
absolutely.
it's quite important. Um, and I just talked about some mechanical parts, but let's say there are electronics.
Hmm.
See a lot of clients who start with an Arduino module, and then they program it, and they get it to activate, get information from a sensor, activate a motor, turn a light on, and things like that. And that's really great to refine the concept before you go into, okay, let's spend 100 engineering hours to do all of this electronic design.
No, if you run into problems after that amount of time, I mean, it's just not good.
Yeah, and if you find issues that you need to correct after that amount of time, then you need to make fixes, and it's going to be a drag on morale also of the team. It's like, oh, we just did all of that, and then now it's like thrown in the garbage, and we need to start to redo that part of it. It's not great,
Mm. Mm.
and you wasted time and money.
Mm. We now know what the difference is between, rapid tooling and hard tooling, because you've been into that. We understand that this is about reducing risks. It's about validating and testing. How do these different technologies differ? And, what sort of information can you give about the pros and cons of the options?
Of the different technologies you mean for making plastic parts?
Correct.
Well, sure. So 3D printing allows you, once you have the CAD drawing, of course, the 3D drawing of the part, allows you to get it done like right here. If you have a 3D printer, um, doesn't take much setup, and right here you have one part, 5 parts, maybe a dozen parts, um, and you can use them right away. That's the great thing. Um, but the problem is, as I said, it doesn't have the physical characteristics of the part that you will actually make in production.
Yeah.
You're not going to use 3D printing to make a batch, even if it's 500 products. I mean, the cost is not low, and it's really pretty slow. So don't really count on 3D printing for mass production.
Mm.
Um, the tolerance is not great. Um, you might have to fix the outside of the parts to make them smooth if they have to be smooth, or add a texture, add things on top of it. Because again, it's not very very precise. Yeah. So that's 3D printing.
Mm.
And by the way, it's funny because um, about 2 years ago, 2 or 3 years ago in Shenzhen, we looked for a place that would have a 3D printer that we would just be able to use, to plug into sort of, and to use. And a lot of places, hacker spaces and accelerators and things like that. Oh yeah, yeah, I have a 3D printer, but right now it's not, it's sort of in maintenance. It doesn't work.
Mm.
um, that was a bit frustrating. Now we have our own 3D printer, so it's kind of a nice toy for the R&D guys, but they can really make the parts that they need, much faster without depending on an outside party. Then the other, like the other extreme that I mentioned before is CNC machining. So you have a block of material, and then you have a typically a three-dimensional arm that goes around, position the cutting tool, and zoop, remove some of the material, right? Um, this comes with a high precision, so it can be done really with pretty tight tolerances. That's great. And obviously, not all CNC machines are the same, right? Some of them are more precise and more reliable than others, but um, typically specifications, the tolerances can be tight. Um, it it's also pretty fast, maybe not as fast as a 3D printer, but it's also typically pretty fast. You can use the exact same material that you plan to use for mass production, so can be a bit closer in that respect. That's nice. Um, in some if you want certain kinds of patterns, certain types of texture for the finishing of the parts, uh, it could be done, but it's pretty limited, right? You cannot do anything you want. And yeah, that's the CNC machine. Now,
Okay.
I have to say, sometimes CNC machine is what you're going to use to make certain products in mass production, right?
Mm.
Um, for metal products, typically, not really for plastic products, but for some metal parts, um, often the competitor, if I may say that, is casting, die casting. Basically, it's also molding, right? You have some molten metal, some kind of alloy of aluminum or whatever, uh, steel, and there's a lot of different alloys. That is how to say that goes into a mold, and then under a certain pressure and temperature for a certain cycle, and out comes a metal part with your custom design. Okay, so it's the metal equivalent. Uh, I should not say that, because there's something that they call MEM, metal injection molding, that's much closer to plastic injection molding, but it's the same general idea. It's you
Mm.
put the material in a mold, you let it cool down, it gets hard, and you take it out.
Yeah.
Uh,
Okay.
so in some cases for metal products, you're going to have to choose between CNC machining and die casting, and it really comes with very different pros and cons. Um, Die casting, yes, the how to say, you will consume less material because you just pour the amount of material that you want um, into the mold, and then you get your part. However, it tends to be a little bit porous or very porous. It depends on the alloy, the settings of the machine, and so on. And the problem with a porous surface is that you cannot do certain types of finishing. So a lot of products come to us with some really nice looking products, and then they say, well, I need to be anodized, because when it's anodized, wow, we can make it in that color, and it's beautiful. That's right, but then are you going to fight the fight of anodizing over a cast part? You know, um, do you want to do that?
Mm.
Are you going to have the volumes to get a really good manufacturer handling the casting and the anodizing interested? If not, it might not be a good idea. You might have 30% rejects or more, right?
Mm.
And then the cost is going to go up, and it's going to be frustrating to everybody. So in that case, it's probably better to do CNC machining. And then after that, since after the CNC machining, you can do anodizing, you can do a lot of types of finishing, right? So
Mm.
CNC machining, we put it here because often it's used to do rapid prototyping for good reason, but it's also definitely something for mass production. And just like the 3D printing machine, we had to buy our own CNC machine. And the good thing about that is we have a CNC engineer, and you know, if we make some parts with the CNC machine, and then mass production is going to be also with the CNC machine, we can tell the company that will do the CNC machining, hey guys, this is the setting, and yes, you can make it, um, cut at that speed, that many rotations, it works fine. There's going to be fewer hours of the machine, so we have to pay you less, but we know it's fine because look, we do it ourselves and it works fine.
Mm.
And you don't trust, okay, you say that sorry, only works on a small series, okay, then we make 1000 and then come and have a look if it works fine. Oh, it works
Yeah.
fine. You see, make
Yeah.
it faster.
Mm.
Right? Because you often run into these factory bosses in China that say, maybe forget it, that doesn't work, I know better, we've been doing that for 20 years. And you're like, okay, so you don't want to test it? You don't want to do an experiment? Okay, so I have to do the experiment and prove it to you, to your face. And then, now you cannot say no, right? Sometimes it's the only
Mm.
way.
Yeah, no, that makes a lot of sense. And prototype development, it is definitely one of the services that we do. So yeah.
Yeah, when it's a good fit for our competencies. Yeah.
Mm. Okay.
Um, and then after that, um, yeah, you go into the different kinds of tools. So as I said, if you want, if you just want to make a few shots, because when you're talking about mold, you don't talk about pieces or number of parts or whatever. You talk about shots. Sometimes they can have several cavities to make several parts at the same time. So
Yep.
silicone rubber, you can make 5, 10, maybe 20 shots, um, and you can make the mold itself pretty fast. Actually, we describe how to make it, on the page that you mentioned. That's
Yes.
from our website. So you make the silicone mold, and then after that you use a thermoplastic polymer that has a much lower melting point, obviously, and it gets into the mold. You close the mold. You let the wood thing, uh, solidify, cool down. You take it out, and you know um, again, you cannot make parts with high accuracy here. Forget about low, very tight tolerances. It's not
Yep.
going to be very, very precise, but it's pretty fast. It's
Mm.
pretty fast. Now, you are not going to do that for mass production. Again, 20 shots, 25 shots, and and that's it. And if you multiply the cost of the mold to make 1,000 parts, forget it. It's going to be very expensive.
Yeah.
So this is to but this is quite useful because you can get some parts that are in the right polymer, the right material, and you can then test your product, including performance testing, reliability testing already, to see where the weaknesses are, to see how it behaves, to see if you need to adjust the product design. And if you need to adjust it, then after that you make a new mold, you make some new parts, you test them again. The turnaround time is days. It's
Mm.
not weeks or months.
Yeah.
So that's the big advantage of
Yeah.
using silicone rubber.
Yeah. So it's effectively like a temporary mold that you can just use to just get a few prototypes.
Right, right. Yeah,
Yeah.
exactly. Yeah.
Okay.
And then, well, I'm gonna skip on aluminum and hybrid of aluminum and steel because in
Hmm.
China we don't really see that. Then it goes into steel, and you have different grades of steel. Some are much softer. So if you don't want to spend a lot of money, and if you don't want to invest for a lot of shots, then go ahead with soft steel. Now it's still going to take probably more than a month, right? That's the problem. So you still need to be relatively sure about your product design before you go into that. Usually you would do that after you have a look good and a looks alike and work alike prototype approved, right? This is when you prepare for mass production already, right? Before that, play with 3D printing, CNC machining, and silicon molds, and maybe some other things. I mean, you might use, if the aesthetics are not important, you can use some standard parts already on the market, and you might have to machine them a little bit, make drill a couple of holes, things like that, and then you can use them for your prototypes. That's perfectly fine. And people do that, and it's a good idea. Even, you remember the first Tesla, what is it, the sort of a convertible, relatively small, some made on the basis of a Lotus car.
Okay.
They did not redevelop the wool product. They did that after that with, I don't know, Model S, right?
Right.
But the first one, they actually used some parts from the existing product, including in production, and people were happy to buy it. So it's not ideal because you can't, it might constrain you in a number of ways, but you can definitely do that for your early prototypes. And why not? Some people do it also for production, for their finished products, right? And as long as that key part will will not go end of life, you can still buy it and so on. Why not? People don't really think about these kind of things, but sometimes it's the smart way to do. And
yeah, that's a good workaround.
It's all about creativity. It's all about really opening the eyes and thinking, okay, what are the alternatives? What can we do, right? Development, product design and development. Think wide open at the beginning.
Great. Yeah, that's a good comparison of the different rapid tooling technologies or rapid prototyping technologies in the case of 3D printing and CNC machining that's available, and some of the pros and cons. So before we wrap up for this episode, what are your key tips for an importer who is considering doing rapid prototyping before they start mass production? So maybe just a summary of some of the key points.
Well, the key points, think of your design, make sketches, use clay, use whatever you're comfortable with. Look at similar products. If you can avoid reinventing the wheel and make something that's relatively close to something that exists with one or two key differences, that will make things easier for you, will de-risk the product on the technical side. And another thing is, don't forget about market research and validating that the product actually does solve people's problems. Keep it as simple as possible. A lot of people keep, having ideas and, oh, it would be nice if we could do that and could do that and could do that. Yeah, okay, you got your version 2 or your version 3 here, but for your version 1, if you want to go to market, in 6 months, and you don't want to spend more than $100,000, say, or $50,000, don't add up one of these things. Talk to users to see what's really useful, the one or two things that are really useful, and just focus on that.
Yeah.
Right? It's going to be less expensive to make, less expensive to develop. Go for it, for sure. Then I would say work with an industrial engineer, an industrial designer that you can communicate well with. That's really, really important. And someone who gets your vision. And by the way, we talked with Andy Bartlett a few episodes ago, also about tooling for plastic injection molding.
Yeah.
And he's one of these guys who can really turn just a concept into pretty nice looking designs. When at the stage when you go to a manufacturer, don't spread your designs all over the place. Do a little bit of vetting first. Get them to sign a non-disclosure, non-use, non-circumvention agreement, NNN agreement, before you share anything with them, and get them to sign a development contract, product development contract, before you start to get them to do any kind of development, because otherwise they will say that they own the design sort of, and they might not send you the design files. As shocking as it sounds, it's extremely common in China, right? And yeah, play with it. It's often better to stay a little bit longer on refining the product design, talking to users, thinking of the alternatives, thinking of how to keep it simple, right? Rather than rushing into let's get as fast as possible into tooling and certifications and production and selling. And actually, that's how it's going to take you much longer.
No, absolutely. Great. That's a brilliant summary to top it all off. So yeah, really enjoyed that. Some excellent guidance there for anybody who is wondering how to approach rapid prototyping. So yeah, great. Thanks, Renaud.
Thanks to our listeners. If you enjoyed this, please go into Stitcher, iTunes, wherever you're listening to this podcast. Give us a 5-star, 5 stars if you like it, and a review if you feel like that. I mean, it makes our day. It's always better, always helpful. Thanks a lot.
With that being said, we will see you next time.
Yep. Thank you.
Thanks for joining us. If you've enjoyed today's podcast, don't forget to like and share, and you can subscribe on Apple Podcasts, Spotify, and all other places that you get your podcasts from. See you next time.